This video is brought to you by Li Xueqi, Niren Kaur, and Li Roufei from Sekolah Menengah Kebangsaan Infant Jesus Convent Johor Bahru, presenting the project Hydrogrid.
Hello everybody, I'm Frichi, your news reporter for today. I'm here to talk about a problem everyone faces, floods. Every time it rains heavily, drains get blocked and water floods streets within minutes. What starts as a simple rainfall can turn into traffic jam, property damage, and dangerous conditions for pedestrians.
Thank you, Xueqi, for your insight. Niren speaking here. Let me ask you something simple. How many times have you seen water rising up along the roads during heavy rain? How many times have you struggled to get home from school with soaked shoes and wet clothes? And how often do we just accept it as normal, even though it keeps happening again and again without any real solution?
I'm Rofe here on site, and this is where usually everything begins to go wrong during heavy rain. Did you know that most flooding is not only caused by heavy rain, but by something much more preventable?
Plastic waste, leaves, and everyday rubbish slowly build up inside drains, blocking water flow until the system can no longer function properly. In just a short period of rainfall, a simple blockage can escalate into a full street-level flood.
And that's why we're here to propose a solution.
Introducing Hydrogrid, a special drainage system designed to prevent blockages at the source by separating waste from water flow in real time. Instead of allowing rubbish like leaves, plastic, and other debris to pile up inside drains, Hydrogrid guides the waste into a separate collection chamber, while water continues flowing smoothly through the drainage system.
Without further ado, let's get into the mechanisms of Hydrogrid. How exactly does it work? Firstly, the vortex chamber at drain entry. Water enters the chamber from the side at an angle, not just straight down. Because of this angled entry, the water starts moving in a circular path. The circular chamber shape guides the water into a continuous spinning motion. As more water enters, the spinning becomes stronger and forms a vortex, which is what we call a whirlpool effect. Secondly is our separation principle. Once the water begins spinning, a vortex flow is formed. The spinning creates a pressure difference inside the chamber. Pressure becomes lower at the center and higher near the outer wall. But how exactly does the separation happen? Water flows more easily towards the low pressure center. It spirals downwards into the main drain outlet. Continuous spinning keeps the central outlet clear. For example, leaves, plastic waste, sand, and food particles. These materials have greater mass and inertia than water, so they cannot follow the tight circular flow as easily. Because of this, they experience stronger outward centrifugal effects. They move toward the outer wall of the chamber. This creates a natural separation process, where clean water goes towards the center outlet and the breeze goes towards the outer edge. Unlike traditional drains, the breeze is not trapped immediately on a grill. Flow separation happens continuously while water is moving. But here's the real question. How does Hydrogrid continue functioning effectively even during extreme rainfall? Hydrogrid proposes anti-backflow flood control as a solution. During normal rainfall, water enters through the standard vortex pathway. The flood remains at a low position, internal gates stay mostly closed, and flow remains concentrated for efficient vortex separation. But during heavy rainfall, water level inside the chamber rises rapidly. The floating mechanisms rises with the water level, and as the float rises, it lifts internal expansion gates. Now, even with strong vertex flow, some debris may still stick. So how does Hydrogrid solve this? Firstly, when someone steps near the drain, small mechanical vibrations are generated. Vibrations transfer into the drain structure. This transfers mechanical energy into the system. Normally, trapped leaves remain stuck because of friction, moisture addition, and compression between debris layers. The vibration disrupts the stuck debris, reduces static friction, and loosens compacted waste. Once loosened, the debris re-enters the swirling vortex flow. Rotating water catches the particles again. The breeze gets redirected towards the side perch outlet. This process is called re-entrainment, meaning previously stuck debris becomes part of the moving flow again.
Hydrogrid is designed to filter waste and rubbish from flowing water, allowing clean water to exit back into the drain while collecting rubbish for disposal.
First, we have two inlets for water to flow through. Then, the product has an escape site for trash to enter the bin to be stored until workers come to collect the rubbish and waste. The base of the bin is made out of mesh so that water can be drained. Water will then exit the water chamber via the outlet at the bottom, which releases the water back into the drain without any rubbish in it. A pressure plate is also added, which is connected to a vibrator using wires colored in gray. The product is suitable to be installed in these drains, where the product will be screwed into the structure under the drain cap. This helps to collect trash that can get through the drain and separate it from the water flow into the bin on the side. The bin that accumulates trash will have a special compartment built into the drain structure, which has an access point that allows workers to collect trash easily.
Now, you may be wondering, what are the exact benefits of this product? Well, let's find out together. Hydrogrid helps reduce drain blockage and lowers the risk of flooding by maintaining smoother water flow during heavy rainfall. Its simple and practical design also makes it easier to maintain and suitable for real-world urban drainage systems.
In the future, this system can be further improved by scaling it into a larger drainage model capable of handling greater water flow in real urban environments. It can also be upgraded using stronger and more durable materials, allowing it to withstand long-term outdoor conditions and heavier usage. Additionally, the waste collection system can be enhanced to store larger amounts of debris more efficiently, reducing maintenance frequency and improving overall performance. Since our product is mainly underground most of the time, worker won't be able to know if anything breaks, thus adding a sensor system which sends a notification to a phone or a tablet signaling the worker to repair or replace the product.
Hydrogrid is designed for real-world use in flood-prone locations, such as residential housing areas, schools, or university campuses, as well as city roads and urban drainage systems. It can also be implemented through collaboration with city authorities, construction and civil engineering companies, environmental and waste management agencies to improve drainage efficiency and reducing flood risk. Looking ahead, Hydrogrid has potential to be part of a smarter urban drainage development. As cities continue to grow, managing water flow efficiently will become more important. This concept can be expanded and integrated into larger drainage networks, helping to create and sustain more flood-resistant environment in the future.